Hello everyone. So today we are going to work on an avoidance algorithm. Because we have implemented this dear NPCs to support root motion based locomotion, and because of that we have to sacrifice some of the features that comes with the native navigation system, such as avoiding other characters. So that means when a character bump into another character, there should be a way to there is a default mechanism to avoid that and go around. But since we have customized it to support root motion based locomotion for the NPCs, we don't have that feature anymore. So today we are going to implement a custom avoidance behavior for these NPC characters, so that when one of the characters bump into another, they will nicely avoid them without trying to overcome them by force. So like, for example, look at this guy. When he avoid this character, see, they avoid each other and move within the herd without an issue. Alright, so this is what I'm going to do today. And this episode is sponsored by these generous patrons. Thank you very much for your support. So we have this problem in our deer herd system. So if I make this the number of herd animals in the herd to 40, and since we have implemented a custom AI navigation system based to support root motion, it doesn't have the default avoidance system that comes with the AI navigation. So sometimes when characters go into each other, they get stuck. For example, like here, as you can see here, this character can't go anywhere because he's stuck with the other character. So let's see how we can avoid this scenario. Okay, so if I speed up, you can see, as we have many characters, being jumping onto each other happens more often. Alright, so how can we avoid this? Okay, so first let me go to this character and let's take a look at how does the moment input is applied. So it's like this. We have the navigation path points, which defines the path this character has to take in order to go to the particular destination we want it to go. And then, so this is to get the desired moment. Let's see where we add the moment input. Right, sorry, actually we don't add a movement input. Totally forgot about that, because we are moving the character using the root motion of the animations. So what we do is, we have this get desired moment, if you don't remember, and in order to get this desired movement direction, we play the relevant animation in the character's animation blueprint. So yeah, that's basically what happens. Right, now first let's find a way to identify if we are overlapping with another character. Right, for that let's add another, what kind of a component we need? Maybe another capsule, and it should be larger than this. Okay, like this. So this should overlap with, not dynamic, I'll make it overlap with all other pawns, because we don't need to worry about static objects that we have overlap or dynamic. Yeah, we no need to worry about static objects that overlaps with this, because static objects will be avoided by when we detect the navigation path. Okay, now let's go to on component begin overlap final event of this collider. So here let's get the other character and let's have the other actor. Let's have an actor array. It should be in the type of actor. Actor object. Where's the actor? Right here, and it should be an array. Right, now when we overlap with another actor, I'll get this overlapped actors and do an add unique function. So what this does is it adds this a reference of this actor into this array, and when I make it unique, if I add it twice, this will make sure that actor is added to this array only once. And on component leave overlap, end overlap, I'll get the same array and remove item using the reference like this. Now we can use this array to determine the other characters that currently overlap with the deer character. So it could be another character or another dynamic object, anything. So yeah, when we know that we are overlapping with some other character, what if we again call this NPC move event, so it will refresh the path. Yeah, so for that we need to keep this destination. Let's promote this to a variable. Destination. And here, so we also have this variable to check whether we are moving or not. We set it to true here, and then NPC move itself. Okay, Now if we are moving, let's add the branch. So here let's add a to once node, because well, now that I don't think we need this, but let's see. So the reason to add to do once node is because this should not be called again and again continuously within a short period of time. So let's call NPC move again with the destination and the current acceptance radius, and let's add a delay of, let's say, 1 second, and reset this. So I guess because we have marked this capsule as a dynamic obstacle here, when I again call this NPC move and find the path, this blocking point should be removed. Let's see. No, it doesn't look like it is working. Okay, let's add a print here to see if this function got called. Change path. No, it is not working. Okay, let's try one more thing. Let's visualize this path. Yeah, maybe like this. Get the nav path points, and for each let's have a sequence here. For each point, let's do a line trace by channel, and let's set the debug type for duration. Start is this, end is this, plus upwards, let's say 200 units. So we should be able to see the changed path. I did see some paths, but it's not clear. Okay, then let's try another approach. I'll disconnect this part, and let's go to the place where we have this get desired moment. Right here we return, well, we don't need these parts, let me delete them. And here if AI moving is true, and also we are currently in an active moment, we return the next point of the navigation nav path points. But before that, let me add let me add another branch here. So in this branch I'll get the overlapping actors and get length. That means if there are overlapping actors, we should avoid them. So if this length is larger than 0, if it is false, this path should be executed. If it is true, we should do whatever we have to do in order to avoid the other colliding character. So for now, I'll get the actor in the 0th index and add a return node for the desired moment. Get actor location, get the location of that actor, and also get the location of the current actor. And using this we can determine the direction away from this overlapping actor, like this direction from this one to ourselves, and I'll give it as the desired moment here. Right, now let's see what happens. Why no one is moving? Well, so I printed the values that we get for each of these. So it seems that the character itself is registered as a collided character here, overlapped character here. I'm not sure why that happens, but we can check that. Let's here add another print like this. Append. Collided with, and then let's print whatever the collided character's name and compile. And here I'll set the herd size to 0 so that there will be no any other characters. Now you can see collided with ch stack. So character itself is overlapping, not really colliding, overlapping with itself. So to prevent that, let's do something like this. Let me collapse this. No, no need to collapse yet. Here let's check if other character is equal to self, and a branch only if it is no. Let's add it to this list. Right, now it didn't register itself as a color overlapped character. Now let's increase the herd size back and see if they can avoid each other. Right, they do avoid each other. They don't stay stuck in the same position, but it kind of feels like doesn't look natural. See, but it's definitely better than what we had before. Okay, so let's improve this. First I'll remove that print. Hard to see things because of that. I'll keep this one. And I'll remove this print. Here, instead of instantly removing this other character from the overlapping actors, what if we have some delay, so that we should be able to prevent that staggering effect. Let's see. Yeah, see, now they nicely avoid each other. Shall we speed up and see if they run into any problems? Well, I think it works pretty good. See? Yeah. Okay. Yeah, but I think something is wrong. Because if I speed up and observe, I see like some characters are going on their own way. So instead of following the leader, see, some of them are going over here, some of them are here, some of them are here. And why is that happening? I think it could be because of this delay, because maybe when we have a delay, this reference is invalidated by the time we are trying to remove this element. So I don't need this print anymore. So let's check here, another print like this, removing, and let's print whatever the name of the character. So if we don't have a valid reference here, we should see removing empty and removing, and after that instead of object name we should see nothing. So let's see. No. So far I did not notice only removing. So what's going on? Well, we can eject and select one of the characters who's going away. This is ch follower 5. If I select ch follower 5, you can see it is avoiding this ch stack follower c25. So that means this one has a value in the array that has not been cleared. So how did that happen? So I guess what happens is this end overlap is not called for some reason. Let's skip this delay and see if that behavior happens. If that is the problem, then we need to think of another way to do that. Right, now it seems like the characters are not going away, they are trying to keep up with the leader. Alright, so I guess that delay is the problem somehow. Yeah. Okay, then how to solve this without a delay? What if we convert this part to a macro? Will there be any difference? Let's check. Let's give it a while to continue the simulation. Yeah, same problem happens. That's why this one is going here and that one is going there. Okay, so the macro is not a solution. So we could do something like add a temporary variable here, but we have since we have multiple overlaps, we can't solve this with a single variable. Okay, then let's try this. Overlapping actors. removed overlapping actors. Okay, then let's, whatever we get here, let's add it to this not removed, remove. So let's keep this temporary in this array, the actors that we need to remove from the overlapping actors. So let's do a add unique here like this, and then after a delay can we remove items? Oh no, we can get the remove actors and do for each loop. So all the actors inside this remove overlapping actors will be removed like this. And after it is done, let's clear it. Right, now let's see. Okay, it looks like we have solved the problem. Let's give it some more time. I should have tracked the leader from the beginning. And also I can see some IK problems here. For example, like over there I saw some jittering of the character. Maybe that's because of this speed up, I'm not sure, need to check it later. But anyway, it seems the problem has been solved because they stick together without going any further places. They don't stray away from the leader. See, yeah, I think this one is the leader. They are following. Okay. Alright, so I'll bring it back to the normal speed. So you can see they are nicely avoiding each other. They don't keep walking when they collided with another character. And yeah, so I think we can stop this episode right here. So in the next episode, let's look into implement stuff like alerting them for threats and running away, stuff like that. Okay, let's stop it here. And thank you very much for watching. So if you like to support my work, you can get the membership of the Patreon club. Link would be in the description below. And also the project files will be available for the download here. And thanks for watching. See you in another episode. Goodbye.